Hello everyone, I am Prajwal and today we are going to look at this problem smaller than the element. This problem is rated as easy on CodeChef and you need to know the use of sets to solve this. So guys, if you haven't read the problem yet, go back and read it, try it out and then come back and see the solution. With this, let's begin. In this problem, we are given an array A of size n. So we are given A1, A2 till A of n, and for every I we need to find the largest A of j such that A of j is less than A of I and j is less than I. If this element exists, we will output that, else we will output -1. So let's take an example. Let's consider A as 1, 5, 2, 3 and 6. Now in the output, for 1 we do not have any element that is less than this and is present before this. So we will output -1. For 5 we have 1. For 2 we have 2 elements but 1 is less than 2 and 5 is greater than 2. 1 is the largest element among the elements that are present before 2 and less than 2. So 1 is the answer for 2. For 3 we have 2 elements 1 and 2. We will consider them both but we have to output the largest one. So we will output 2. For 6 it is equal to 5. In the constraints we have n from 1 to 2 into 10 to the power 5 and the elements will range from 1 to 10 to the power 15. Now let us look at an example. So in the first example, we are given n is equal to 5 and array A is given as 1, 2, 3, 5, 4. So for 1, we do not have any element that is less than this and is present before this. So the answer is -1. For 2, we have only one element 1 which is less than this and is present before this. So the answer is 1. For 3, we have two elements 1 and 2 that are less than 3 and are present before 3. So we will consider the largest, which is 2. For 5, we have the 3 elements 1, 2, 3. So the answer is the largest, which is 3. For 4, we only have 3 elements, which is 1, 2, 3, that are less than 4 and are present before 4. So we will consider the largest, which is 3, as given in the output. Moving on to the solution. So in this problem, we are given an array A of n elements and we have to find for every I the largest j, the largest A of j, such that j is less than I and A of j is less than A of I. So one of the approaches that might come to your mind is to run a two loops, first for all I from 0 to n, and let's have a variable answer initialized to -1. And now we will run a loop from j is equal to I minus 1 to 0. Basically we will check for every A of I, we will check all the elements that have come before this and among them we will find the largest. So if A of j is less than A of I, then both of our conditions are satisfied. In this case, we will update our answer as answer is equal to max of answer comma A of j. And finally, we will print our answer. We will do this for every I. So the complexity of this solution is order of n square, which will give you TLE because n ranges from 2 into 10 to the power 5. However, the original solution is not far away from this. Instead of looking at every position, what we can do is we can use a set to maintain a sorted order of all the prefix of current variable I. So let us say that we have this sequence A1, A2, A3, A4 and A5. And suppose we are finding answer for A4. This is our current I. So we will use a set that will maintain A1, A2 and A3. And this will be in sorted order. So now when we want to find A of j such that A of j is less than A of I but A of j is largest in set. So to do this we can use a function lower bound. What this function does is it performs binary search on the sorted sequence in the set, and it will return you the maximum element greater than equal to the element that we search for. So if we search for some a of k, then it will return the maximum element greater than equal to a of k. So now to get the largest element less than equal to a of I, what we can do is we can perform lower bound a of I on this set. So let's say that our set is a1, a2, a3, a4 and a5, and we are trying to find the answer for a6. So we will basically perform lower bound of a of 6 in this set. So let's say that these two elements are greater than a of 6 and these three elements are less than a of 6. Then we will get the position of this element, because this is a4 is greater than equal to a6. And when we get this position, we can just subtract by 1. We can subtract the iterator by 1 to get this, and this is our answer. This is the highest a of j, which is less than a of 6, but a of 3 is largest among all the numbers, among all considered numbers. So when we are trying to find the answer for a6, we will only consider all the numbers that are smaller than a6 and occur before this. So in currently we have all these numbers, these two elements are larger, so we will consider only a1, a2 and a3 because they are smaller. Now we need to choose the maximum, so we will perform a lower bound of a6, which will return us the iterator of a4. Now we will shift this by 1 and we will get our maximum, because a set maintains a sorted sequence. Moving on to the implementation. So given an array A of size n, we will maintain a set and we will iterate over all the elements of A. We will perform a lower bound on this set with the value a of I, and we will get an iterator such that the value is greater than equal to a of I of this iterator. If this iterator is the first element of this set, then we know that there does not exist any element which will be less than this a of I. So we will print -1. Else there exists an element, so we decrease our iterator by 1, which will return a value that is less than a of I but is the largest one, and we will just print it. Finally, we will insert this a of I in back to our set. So the time complexity for this solution is order of n log n. This is an order n loop and the set operations are order log n. The space complexity is order of n, because we need to maintain this set and store the initial array. Moving on to the code. So we start by taking the input and then we create this set with the initial element as ARR0. For the first element, we know that the answer will always be -1. Now we iterate from 1 to n and do a lower bound on this set with the value ARRI. If the iterator that we get is the first element, then we know that our answer is -1. So we push -1 to our answer variable. Now we decrease our iterator by 1 if it is not the first element, and we push the value of the iterator, which is star of v, back to our answer variable. And finally we will push ARRI back to our set. Now we have to print our answer. So guys, this is pretty much the whole code. Try to code it yourself, and if you face an issue, then come back and see it again. So guys, I hope you understood the problem clearly. If you have any questions, drop a comment in the comment section. Like the video and don't forget to subscribe to get our latest updates from CodeChef. Thank you and goodbye.